What if the most dangerous places on Earth were once considered the most sacred? What if our ancestors didn't build their temples in spite of the trembling ground beneath them, but because of it? There's a temple in southern Turkey that shouldn't exist. Not because it's too old, though it is older than Stonehenge, older than the pyramids, older than writing itself. It shouldn't exist because it sits directly on top of one of the most active fault lines in the ancient world. A fracture in the Earth's crust that has swallowed cities whole, that has rewritten coastlines, that has ended empires with a single shudder. The archaeologists who uncovered it in the 1990s assumed it was coincidence. After all, in a geologically active region, almost anywhere you dig might intersect with some degree of seismic risk. But then they found another temple, and another, and slowly, impossibly, a pattern emerged that challenges everything we thought we knew about ancient engineering, about religious practice, about the very relationship between humanity and the living earth beneath our feet. If you're drawn to the kind of history that refuses to stay buried, that whispers from beneath stone and soil, then perhaps you'll want to stay with this journey. Consider liking this exploration if it resonates with something ancient in your own awareness. And tell me, where are you listening from tonight? What ground are you standing on? And do you know what moves beneath it? Because here's what nobody tells you in history class. The first civilization we know of that built permanent structures, that carved stone and raised monuments to last millennia, chose to build them in the exact places where the earth itself was most likely to destroy them. We call this civilization by many names: the temple builders of Göbekli Tepe, the megalith workers of Çatalhöyük, the stone circles of the Anatolian plateau. But perhaps we should call them what they truly were: the first people to listen to the earth and to build shrines where its voice spoke loudest. The conventional explanation is that these ancient peoples simply didn't know, that they were ignorant of seismology, unaware of tectonic theory, blind to the danger that modern instruments can now measure with precision. We imagine them as primitives, choosing sacred sites based on superstition or convenience, on the presence of a spring or the shape of a hill, never understanding that the ground beneath their bare feet was a sleeping giant that might wake at any moment. But what if that explanation is backward? What if they knew something we've forgotten? Consider the evidence as it stands today, mapped and measured by modern geological surveys. Göbekli Tepe, that impossible temple complex dated to approximately 9,600 BCE, sits less than 200 kilometers from the East Anatolian Fault, a major transform boundary that generates significant earthquakes even in our current era. The temple wasn't built near the fault line. It was built in a zone of measurable seismic activity, where the ground itself carries a constant, subtle vibration, a frequency too low for human ears to hear but present nonetheless, a hum in the bones of the world. Move westward across Anatolia and you find Çatalhöyük, one of the earliest urban settlements known to archaeology, dated to approximately 7,500 BCE. Modern seismic monitoring has revealed that this ancient city sits in a region of complex fault interactions, a place where multiple fracture systems converge beneath the surface. The houses there were built and rebuilt, layer upon layer, generation after generation, always in the same location despite the earthquake damage visible in the archaeological record. They didn't move. They stayed and they rebuilt as if the location itself mattered more than safety, more than survival. Cross the Mediterranean and the pattern continues. The Oracle of Delphi, perhaps the most famous prophetic site in the ancient world, rests directly above the intersection of two major fault lines. Modern geologists have confirmed that this intersection creates a unique geological phenomenon: the constant release of hydrocarbon gases through fissures in the limestone bedrock. The Pythia, the oracle priestess who delivered prophecies in a trance state, sat directly over one of these fissures, breathing in ethylene and other vapors that modern analysis confirms would have produced altered states of consciousness. The ancient Greeks claimed she could hear the voice of Apollo rising from the earth. What if she was hearing something else? The voice of the earth itself, speaking through chemistry and pressure, through the slow grinding of continental plates. The temples of ancient Peru tell the same story. Chavindahuantar, built around 900 BCE in the Andes, sits in one of the most seismically active regions on Earth, where the Nazca Plate subducts beneath the South American plate in a slow-motion collision that has shaped the very mountains. The temple complex there includes a sophisticated system of underground galleries and water channels that, according to recent acoustic studies, would have created strange sound effects during earthquakes, amplifying the seismic waves, transforming them into audible roars and whistles that filled the sacred spaces. The priests didn't flee from earthquakes. They built instruments to hear them more clearly. Japan's ancient Shinto shrines follow a similar pattern. Many of the oldest sacred sites sit in locations that modern seismic monitoring has identified as particularly active. The Grand Shrine of Ise, rebuilt every 20 years in a ritual that has continued for over a millennium, sits in a region subject to regular tremors from the Philippine Sea Plate's interaction with the Eurasian Plate. The shrine's architectural design, raised on pillars, built without nails, flexible in its wooden construction, represents what modern engineers recognize as sophisticated earthquake-resistant technology, developed not through mathematical modeling but through centuries of careful observation and adaptation. We're looking at a global pattern, one that spans cultures that supposedly had no contact, that developed in isolation from one another across vast distances and millennia of time. And yet they all seem to share one inexplicable practice. They built their most important structures, their temples and oracles and sacred centers, in the places where the earth moved. Why? The modern mind recoils from the question because it seems to have no rational answer. We've spent centuries learning to avoid geological hazards, to map fault lines so we can build our cities away from them, to develop building codes and engineering standards designed to minimize seismic risk. The idea that ancient peoples would deliberately seek out these dangerous zones seems like madness, unless we're misunderstanding what they were seeking. There's a story carved into the walls of Göbekli Tepe that nobody quite knows how to interpret. Among the elaborate pillars decorated with carved animals, scorpions, vultures, serpents, and strange anthropomorphic figures, there's a recurring symbol that appears again and again, a serpent or zigzag line that runs vertically down the stone. Early archaeologists assumed it was decorative or perhaps symbolic of water. But in 2017, a team of researchers proposed something different. They suggested it might represent seismic waves, a visual record of the Earth's movement, carved in stone by people who had no written language, no mathematical notation, no scientific instruments, yet who somehow understood that the ground itself moved in waves. The evidence for this interpretation is indirect but compelling. The zigzag pattern appears most frequently on pillars that face toward the East Anatolian Fault. The frequency and amplitude of the carved waves vary from pillar to pillar, almost as if they're recording different magnitudes of shaking. And in several instances, the pattern is associated with the carved animals in ways that suggest meaning, serpents rising. From the zigzag lines, scorpions positioned as if riding the waves of stone. Could they have been recording earthquakes? Could a pre-literate society have developed a system for documenting seismic activity without writing, using only image and symbol and the patient work of stone carving? It sounds impossible. And yet we know they were capable of astronomical observation precise enough to align their structures with solstices and equinoxes. We know they understood geometry well enough to plan and execute construction projects that required coordinating the labor of hundreds of people over decades. We know they had the cultural continuity to maintain building projects across generations, to preserve knowledge and pass it forward through time. Why couldn't they have also developed the observational skills necessary to recognize patterns in the Earth's movement? The Greek myths speak of individuals called the Telchines, mysterious figures who lived before the Great Flood, before the age of gods and heroes. According to the fragments that survive, the Telchines possessed the ability to predict earthquakes and volcanic eruptions. They were described as metalworkers and magicians, but also as earth watchers, individuals who could sense changes in the ground before disaster struck. The myths say they eventually fled to Rhodes and other islands, driven away by jealous gods or by the very catastrophes they had learned to predict. We read these stories as fantasy, as primitive attempts to explain natural phenomena through supernatural agency. But what if they're garbled memories of something real, of a tradition of seismic observation that existed long before Aristotle or any other philosopher tried to explain earthquakes through natural causes? The Chinese historical records contain similar figures. The Dijin-yi, or earthquake weather vane, supposedly invented by the polymath Zhang Heng in 132 CE, is often described as the first seismic detector. It was an elaborate bronze vessel with 8 dragon heads, each holding a ball in its mouth. When an earthquake occurred, one of the balls would drop into the mouth of a towed position below, indicating the direction from which the seismic waves had come. Modern seismologists have confirmed the design would have worked. The pendulum mechanism inside would have responded to ground motion, triggering the release mechanism. But here's what's rarely mentioned. Zhang Heng claimed he was not inventing the device, but restoring it. The historical records state that similar instruments had existed in deep antiquity, in the time before the Yellow Emperor, in the age when the earth was young and humans still remembered how to listen to its voice. Restoration, not invention. The same word appears again and again in ancient sources when they describe technological or philosophical achievements. The megalith builders of Europe, the pyramid constructors of Egypt, the astronomers of Babylon, they all spoke of their work in terms of recovery, of remembering, of restoring what was lost. We assume this is mythological thinking, a way of lending authority to new ideas by attributing them to an imagined golden age. But perhaps we should take them at their word. Perhaps there was something to restore. Because here's the unsettling part, the detail that modern archaeology has been slowly, reluctantly uncovering. Many of these ancient seismic sites show evidence of repair and rebuilding that predates their supposed construction. At Göbekli Tepe, the earliest layers contain worked stone and architectural elements that appear to have been salvaged and reused, as if the builders were working with materials from something even older, something that came before. The same pattern appears at other megalithic sites, standing stones that show weathering inconsistent with their supposed age, suggesting they stood somewhere else first, for a longer period, before being moved to their current locations. What were they rebuilding? What were they restoring? And most disturbing of all, what knowledge were they trying to preserve? The answer might lie not in what these ancient peoples built, but in where they built it, and how those structures interact with the living earth beneath them. Because recent studies using ground-penetrating radar and seismic monitoring equipment have revealed something extraordinary about these ancient sites. Something that suggests their relationship with earthquakes was far more sophisticated than mere observation or record-keeping. The structures amplify seismic waves. Not all waves and not in all directions. But specific frequencies, specific patterns of ground motion, are enhanced by the architecture itself. The discovery came almost by accident. In 2011, a team of geophysicists studying earthquake early warning systems in Turkey set up a network of sensitive seismometers across the Anatolian Plateau. They were looking for ways to detect the initial P waves of earthquakes, the faster-moving compression waves that arrive before the more destructive S waves and surface waves. One of their monitoring stations was positioned near Göbekli Tepe, and during a moderate earthquake about 300 kilometers away, the instruments recorded something strange. The seismic signals at the archaeological site were stronger and more clearly defined than at other nearby locations, despite the fact that nothing about the local geology should have produced that effect. At first they thought it was an equipment malfunction. But repeated measurements during subsequent earthquakes confirmed the pattern. Something about the arrangement of stone at Göbekli Tepe was resonating with specific seismic frequencies, amplifying them, making them more detectable. The effect was strongest in the underground chambers and in the spaces between the carved pillars. Exactly the places where ancient peoples would have gathered for ritual or ceremony. They would have felt the earthquakes more strongly there. Not dramatically, not dangerously, but noticeably. A tremor that might be barely perceptible in the open countryside would become a distinct sensation in the temple complex. A vibration in the stone, a hum in the air, a physical presence that you could feel in your chest and bones. Was this intentional? Did the builders understand acoustic and seismic resonance well enough to design structures that would amplify specific frequencies? The modern mind rebels against the idea because it seems to require knowledge of physics and mathematics that supposedly didn't exist in 9600 BCE. But acoustic resonance doesn't require equations. It requires careful listening and patient experimentation. You don't need to understand harmonic theory to notice that certain spaces make sounds louder, that certain arrangements of stone create echoes and reverberations, that the earth itself seems to speak more clearly in some places than others. And if you're a culture that believes the earth has a voice, that its movements carry meaning and message, then building structures that let you hear that voice more clearly isn't superstition, it's engineering in service of perception. The same resonance effect has now been documented at other ancient sites. The stone chambers of Newgrange in Ireland, built around 3200 BCE, show acoustic properties that amplify low-frequency sounds, including the kind of infrasound generated by seismic activity. The underground galleries at Chavín de Huántar in Peru were designed with water channels that create specific sound effects during ground shaking, transforming seismic waves into audible roars that would have filled the sacred spaces. The inner chambers of the Great Pyramid at Giza have acoustic properties that some researchers believe were designed to resonate with the natural frequencies of the bedrock beneath them. Frequencies that would be excited by distant earthquakes, creating a hum that could be felt but not heard. These weren't just buildings. They were instruments. Instruments for listening to the earth. But listening to what exactly? What information could you gain from feeling earthquakes more intensely? What practical purpose could it serve? Consider what modern seismology has learned about earthquake prediction in the last few decades. Despite all our technology, despite networks of sensors and satellites and supercomputers running complex models, we still cannot reliably predict when an earthquake will occur. We can identify regions of high risk, we can calculate probabilities over long timescales, but we cannot tell you that a major earthquake will strike next Tuesday at 3 p.m. The physics of fault rupture are too complex, too sensitive to initial conditions, too dependent on variables we cannot measure. But there are precursors. Small signals that sometimes appear before large earthquakes. Subtle changes in the patterns of background seismicity. Variations in the rate of small tremors. Shifts in the way seismic waves propagate through stressed rock. These signals are not reliable enough for formal prediction, but they exist. The earth does whisper before it shouts, if you know how to listen. And here's the crucial point. These precursor signals are often strongest at specific frequencies in the infrasound and low-frequency sound range that human ears cannot detect but that human bodies can feel. Frequencies that would be amplified by the acoustic properties of structures like Göbekli Tepe or Newgrange or Chavín de Huántar. If you spent your entire life in such a structure, if your culture maintained a tradition of observing and recording the sensations felt in these sacred spaces, if you developed a vocabulary of feeling to describe the different qualities of vibration and resonance, might you begin to recognize patterns? Might you notice that certain sensations tend to precede larger shaking events? Might you develop an intuitive sense, impossible to quantify or prove, but statistically significant over many years of observation, of when the earth was building toward rupture? We know that some animals can sense earthquakes before they occur. Dogs and cats display unusual behavior hours before seismic events. Elephants have been observed moving to higher ground before tsunamis. Fish swim in unusual patterns. Birds take flight en masse. The mechanisms aren't fully understood. Some researchers think the animals detect changes in groundwater chemistry. Others suggest they're sensing electromagnetic variations or responding to precursor tremors too small for humans to notice without instruments. But the phenomenon is real. Animals can feel something we cannot, or rather, something we can no longer feel, because we've lost the cultural context and the architectural tools that would make such subtle perceptions possible. The ancient earth watchers, the ground listeners, the priests who sat in resonant chambers and felt the planet breathe beneath them. What if they were developing a sensitivity we've since abandoned? What if they were training their bodies to become instruments, learning to recognize patterns in sensation that our modern, instrument-mediated approach to seismology has never considered? There's an account from ancient Greece, recorded by the historian Diogenes Laertius, about a philosopher named Anaximander who supposedly predicted an earthquake in Sparta. The story is usually dismissed as legend, but the text is specific about the method. Anaximander is said to have observed unusual stillness in the wells and springs around the city, combined with strange behavior in animals and a quality of oppression in the air. Modern seismologists recognize some of these signs as potential earthquake precursors: changes in groundwater levels due to stress accumulation in rock, electromagnetic effects that might influence animal behavior, atmospheric phenomena related to gas release from stressed fault zones. But Anaximander supposedly integrated these observations into a prediction specific enough to warn people to leave their houses, and according to the account, the earthquake struck that same day. Was he lucky? Was the story fabricated? Or was he the last practitioner of a tradition that had been observing and recording such patterns for thousands of years before him? A tradition whose knowledge was already fragmenting and being lost by the time of classical Greece. The pattern we're uncovering suggests that seismic observation wasn't just the work of isolated individuals. It was institutional, encoded in architecture and ritual, preserved across generations through practice rather than writing. The temples weren't places where priests went to escape the mundane world. They were monitoring stations, carefully positioned in zones of seismic sensitivity, designed to amplify the signals the Earth was sending, staffed by individuals trained from childhood to recognize and interpret the subtle language of ground motion. And this raises an uncomfortable question. If they could feel earthquakes coming, what else could they sense? Because seismic activity doesn't occur in isolation. Fault zones are regions of intense geological activity, places where heat flow is elevated, where fluids circulate through fractured rock, where the chemistry of groundwater changes in response to stress, where gases seep from depth. The same fractures that allow earthquakes to occur also create pathways for the Earth's interior to communicate with the surface. And some of what emerges from those pathways can alter consciousness. We've already mentioned Delphi and its hydrocarbon gases. But the phenomenon is more widespread than one famous oracle. Many ancient sacred sites sit above geological features that release psychoactive vapors, carbon dioxide, hydrogen sulfide, radon, and various organic compounds produced by thermal decomposition of buried organic matter. In low concentrations, these gases can produce mild euphoria, altered perception, vivid dreams, and the sense of presence or communication with something other than oneself. The ancient peoples didn't understand the chemistry, but they understood the effect. They called these places oracles, gateways to the divine, portals through which the gods spoke. And they positioned their most important sanctuaries at the exact geological features that produced these effects. Now combine this with seismic sensitivity. Imagine a temple built on an active fault zone, designed to amplify seismic vibrations, located above a fracture system that releases consciousness-altering gases. You have an environment that would enhance perception in multiple ways, making you more aware of subtle ground motion, altering your mental state in ways that might increase pattern recognition or intuitive thinking, creating an experience of direct communion with forces beyond normal human awareness. Was this accident? Or was it a sophisticated technology for accessing forms of knowledge that our modern, rationalist framework struggles to recognize as valid? The archaeological record suggests deliberate design. At Delphi, the Temple of Apollo was rebuilt multiple times over centuries, always in the exact same location, always positioned to maximize the priestess's exposure to the gas-emitting fissure. At Göbekli Tepe, the underground chambers were carved deeper into bedrock than structural necessity would require, as if the goal was to get closer to something below. At Chavan-Huantar, the interior galleries create a disorienting maze of sound and shadow, with narrow passages that force visitors into specific postures and movements, leading ultimately to a central chamber where the most intense acoustic and possibly chemical effects would be experienced. These weren't just temples. They were technologies for altered states, designed and refined over centuries, using architecture and geology in combination to produce specific psychological and perceptual effects. And at the center of all this is earthquake prediction, or more precisely, earthquake awareness. The ability to feel the Earth's stress building, to sense the approach of rupture, to know when to move and when to be still, when to reinforce structures, and when to evacuate, when to prepare, and when to take shelter. For a pre-industrial society living in a seismically active region, this knowledge would be survival critical. A culture that could predict earthquakes even imperfectly, even just a few hours in advance, would have enormous advantages. They could move livestock to safety, secure food stores, position people away from vulnerable structures. Over generations, this would translate into better survival rates, more cultural continuity, greater ability to maintain long-term building projects and agricultural development. It would make you look to later observers like you had divine protection, like the gods favored you, like you possessed wisdom beyond ordinary human capacity. And maybe you did, but not supernatural wisdom, empirical wisdom, hard-won through centuries of careful observation, encoded in architecture and ritual, passed down through initiatory training that taught people to feel what the earth was saying. The Romans had a word for this: augury, the practice of reading signs in nature to predict future events. We remember it mostly as bird-watching, augurs who studied the flight of birds to divine the will of the gods. But the oldest forms of augury involved reading the earth itself, the movement of animals, the behavior of springs and wells, the quality of air and light, and yes, the subtle trembling in the ground. The augurs were priests, but they were also observers, maintaining a tradition of attention to natural phenomena that stretched back to a time before Rome, before Greece, before history itself had a name. What if earthquake prediction wasn't the only knowledge preserved in these seismic temples? What if the Earth listeners were monitoring other phenomena as well: volcanic activity, tsunami risk, climate patterns, groundwater availability? Because here's what modern geology has revealed about fault zones. They're not just fractures in rock. They're dynamic systems where everything connects. The same stresses that cause earthquakes also affect groundwater flow, heat distribution, gas release, and even local weather patterns. A major earthquake can change the flow rate of springs hundreds of kilometers away, can trigger volcanic eruptions, can alter ocean currents and atmospheric circulation. The Earth is a system, and fault zones are places where that system's interconnections become visible, where changes in one variable ripple out to affect everything else. If you were observing such a system for generations, you might begin to see those connections. You might notice that certain configurations of natural signs tend to cluster together, that changes in spring flow correlate with changes in animal behavior, that unusual cloud formations appear before ground shaking, that the quality of plant growth varies with subtle shifts in heat flow from below. You wouldn't understand the physics, but you'd recognize the patterns. And you'd encode that pattern recognition in the architecture of your sacred spaces, in the rituals performed there, in the training given to each generation of observers. Knowledge preserved not in writing, which can be lost or destroyed, but in practice and place, in the actual physical relationship between human bodies and geological processes. There's evidence for this kind of long-term environmental monitoring in the archaeological record, but it's subtle and easy to miss if you're not looking for it. The standing stones of the British Isles, for instance, seem to have functioned as markers for various natural phenomena, astronomical alignments, yes, but also water sources, mineral deposits, and locations significant for reasons we don't fully understand. Some researchers have noted that many stone circles sit on geological boundaries or near fault lines, and that the stones themselves are often composed of rock types with interesting electrical or magnetic properties. Could they have been part of a monitoring network? Markers positioned to track changes in the earth across a landscape, maintained by a culture that understood the land as a living system requiring observation and care? The idea seems far-fetched until you consider the timescales involved. These stone monuments were erected over thousands of years, maintained across countless generations, representing an investment of labor and resources that only makes sense if the society placing them derived real, practical benefit from their existence. We assume the benefit was purely ritual or astronomical, but what if it was also environmental? What if maintaining the stone network was how these cultures monitored their world, how they tracked the slow changes in geology and climate that could spell the difference between prosperity and disaster? The mythology supports this interpretation. Celtic legends speak of druids who could predict storms and earthquakes, who knew when rivers would flood and when droughts would come, who understood the voice of the land in ways that seem magical to modern ears. But strip away the supernatural elements and you're left with accounts of individuals who spent years in training, who observed natural phenomena with meticulous attention, who maintained a body of knowledge about environmental patterns and correlations. That's not magic. That's science, empirical, observational science conducted without instruments, encoded in memory and practice rather than mathematical notation. The same pattern appears in indigenous cultures worldwide. Australian Aboriginal peoples maintain knowledge of water sources, animal migration patterns, and seasonal changes that scientists are only now beginning to recognize as sophisticated environmental monitoring. Polynesian navigators could predict storms and find islands across thousands of kilometers of open ocean using subtle observations of wave patterns, cloud formations, and bird behavior. Andean cultures track time and seasons through observations of stellar positions, solar alignments, and the growth patterns of specific plants. And many of these traditions included earthquake awareness. The Maori of New Zealand have stories of Ruamoko, the god of earthquakes, and traditional protocols for responding to ground shaking that suggest generations of experience living in one of the most seismically active regions on Earth. Native American cultures along the Pacific coast have flood stories and earthquake warnings encoded in oral traditions, warnings that modern geologists have confirmed correspond to actual megathrust earthquakes and tsunamis in the region's past. These aren't primitive superstitions. They're cultural memory systems, ways of preserving crucial survival information across timespans longer than written history. And the seismic temples, the earthquake monitoring architecture of the ancient world, were part of that same tradition, a global heritage of environmental awareness that we've largely lost and are only beginning to rediscover. But here's where the mystery deepens, where the comfortable categories of lost knowledge and ancient wisdom become insufficient to explain what we're finding. Because some of these seismic sites show engineering sophistication that shouldn't be possible for their supposed age. Not impossible in the sense of requiring advanced technology or mathematics, impossible in the sense of requiring knowledge that should take many generations of trial and error to accumulate, yet appearing fully formed in the archaeological record. Göbekli Tepe is the classic example. The oldest megalithic temple complex we've found. It displays architectural and artistic sophistication comparable to much later civilizations, but with no apparent precursors. The site's excavator, Klaus Schmidt, called it a cathedral on a hill, an expression of religious and organizational complexity that shouldn't exist in a world of scattered hunter-gatherer bands. The conventional explanation is that we simply haven't found the earlier sites yet, that there must be a gradual progression from simpler to more complex structures, and that future archaeology will fill in the gaps. But what if the progression went the other way? What if Göbekli Tepe isn't the beginning of the temple-building tradition, but rather one of the later expressions of it, a restoration project, as the builders might have said themselves, an attempt to preserve and continue something that was already ancient in 9600 BCE? The evidence for such an interpretation is circumstantial but haunting. The very oldest layers of Göbekli Tepe contain the most sophisticated carvings, the most precise stonework, the most ambitious architectural designs. The later layers show progressive decline, simpler pillars, cruder art, less ambitious construction. That's the opposite of what you'd expect from a technology in development. Technologies improve over time as knowledge accumulates. But sometimes they degrade when knowledge is being lost rather than gained, when a civilization is trying to maintain practices it no longer fully understands. What if the megalithic builders weren't inventing earthquake monitoring? They were trying to preserve it, to keep alive a tradition that came from somewhere else, from some earlier time or place. This is where we enter territory that makes conventional archaeologists uncomfortable, because it implies discontinuity in human cultural development, suggests that our models of steady progress from simple to complex might be wrong. But the evidence keeps accumulating. The Sphinx in Egypt shows water erosion that some geologists argue requires thousands of years more rainfall than the Sahara has seen in historical times, suggesting the monument is far older than Egyptology claims. The underwater structures off the coast of Japan, India, and the Mediterranean show architectural features that were last above sea level before the end of the Ice Age. Genetic studies reveal population bottlenecks and migrations in the human past that correspond to massive climatic upheavals. The Younger Dryas cooling event 12,800 years ago, the meltwater pulses that raised sea levels by hundreds of feet, the catastrophic floods that filled the Black Sea and Persian Gulf and drowned vast coastal plains where archaeological evidence suggests sophisticated cultures had developed. What if the seismic temples we can still see are the survivors, the high-elevation monuments built by cultures that watched their world drown, that saw their cities swallowed by rising seas, that fled inland and upward and tried to preserve what they could of their knowledge and practice? The mythology speaks to this directly. Every culture on Earth has flood stories, tales of a time when the waters rose and the old world ended. We've tended to see these as exaggerated memories of local floods, or as universal archetypes emerging from the human unconscious. But modern geology has confirmed that catastrophic flooding did occur at the end of the last ice age. Not a single biblical deluge, but a series of meltwater pulses as the great ice sheets collapsed, each one raising sea level by meters or tens of meters, inundating coastal regions, drowning river valleys, transforming the geography of continents. If you were living through such events, if your culture's accumulated knowledge was stored in coastal settlements now buried under hundreds of feet of water, what would you do? You'd move to higher ground. You'd rebuild. And you'd create monuments, physical markers that would outlast wood and clay and textile, monuments positioned in places where the earth itself would help preserve them, where geological activity would keep them visible, would prevent their burial under sediment, would make them impossible to ignore or forget. You'd build on fault lines, not despite the danger, but because of it. Because active geology means exposed bedrock, means resistance to erosion, means your monuments will still be visible thousands of years in the future when your descendants have forgotten almost everything else about you. And you'd encode in those monuments whatever knowledge you deemed most crucial to preserve. You'd orient them to astronomical phenomena so future generations could track time and season. You'd design them with acoustic properties that would teach about resonance and vibration. You'd position them on seismic zones so that the practice of earth listening could continue, so that at least some humans would maintain the relationship with geological forces that had allowed your culture to survive as long as it did. You'd be leaving a message, not written in language which changes and dies, but written in stone and placement, in the enduring relationship between human construction and geological reality. What was the message? Perhaps simply this: the earth speaks. Learn to listen, because that's the core of what we're uncovering. A worldview in which the earth is not inert matter, not a dead ball of rock to be exploited and manipulated, but a living system with its own rhythms and patterns, a system that communicates with those who pay attention, that rewards observation and punishes ignorance. Modern seismology, for all its instrumental sophistication, approaches earthquakes as random events governed by stress accumulation and rupture mechanics, predictable only in statistical terms across large populations of faults. But what if that's not the full picture? What if there are patterns at shorter timescales, patterns visible to dedicated observers but hidden in the noise when you're looking at aggregated data? What if the earth does give warnings, does signal its intentions, but in a language we've forgotten how to hear? Recent research in earthquake science has begun to explore this possibility. Studies of slow slip events, gradual fault movements too slow to generate noticeable shaking, have revealed that these silent earthquakes can sometimes trigger larger, destructive events. The patterns are complex and not yet predictable, but they exist. The earth does show preparation before rupture, does undergo changes that instruments can detect and that, in principle, human observers might learn to recognize. And there's emerging research on electromagnetic phenomena associated with earthquakes, variations in Earth's magnetic field, electrical currents in the ground, ionospheric disturbances that occur hours to days before major seismic events. The mechanisms aren't fully understood, but the correlations are real. Some scientists are now developing earthquake early warning systems based on these electromagnetic signals, using the same principles that ancient earthwatchers might have intuited without understanding the physics. We're rediscovering something, not inventing it, but remembering it, approaching it through instruments and equations what our ancestors approached through direct perception and patient observation. And this raises the most unsettling question of all. What else did they know? What other aspects of the natural world were they monitoring with techniques we've lost and can now barely imagine? The ancient astronomers tracked planetary movements with naked-eye precision that required generations of record-keeping. Their understanding of celestial cycles was in some ways more sophisticated than what emerged in the scientific revolution, because it was based on longer observational baselines, thousands of years of data encoded in monument alignments, ritual calendars, and oral traditions. Modern astronomy had to rediscover many of these cycles, had to build telescopes and develop mathematical models to see what the ancients had seen simply by watching the sky with meticulous attention across vast spans of time. Could the same be true of Earth science? Could ancient cultures have discovered patterns in seismic activity, volcanic eruptions, climate variation, and other geological phenomena through sustained observation spanning not decades but millennia? Patterns that our modern science, with its historical baseline of a few hundred years of instrumental records, has not yet had time to recognize? It seems impossible until you consider the evidence. Indigenous Australian cultures maintained oral histories of coastal geography that modern archaeology has confirmed are accurate descriptions of landscapes that existed more than 7,000 years ago, before rising sea levels drowned them. Polynesian navigators preserved knowledge of ocean currents and weather patterns across an area spanning a third of the Earth's surface. Andean cultures developed agricultural practices adapted to climate variations on timescales of decades to centuries. Knowledge that's now being studied by climate scientists trying to understand El Niño cycles. These are not primitive peoples preserving vague myths. These are sophisticated observational cultures maintaining precise knowledge across timespans that dwarf modern science's historical record. And the seismic temples suggest that earthquake monitoring was part of that same tradition, a practice sustained for millennia, refined through countless generations of observers, encoded in architecture and ritual so that it would survive even if the original understanding was lost. We stand in the ruins of those temples now, measuring them with instruments, trying to extract meaning from stone and placement. We marvel at their age, puzzle over their purpose, debate their construction techniques. But perhaps we're asking the wrong questions. Perhaps the question isn't how they built them, but what they heard there. What the earth told them in its slow language of vibration and stress, what patterns they recognized over lifetimes spent listening, what knowledge they preserved in the only way that would outlast catastrophe, by making the listening posts themselves indestructible, by carving them from bedrock in places where geology itself would keep them exposed and visible. There's a site in Malta called the Hypogeum of Halsaflini, an underground temple complex carved into solid limestone around 3600 BCE. The central chamber has acoustic properties that have fascinated researchers. Speaking at certain frequencies in that space produces powerful resonance effects, vibrations you can feel throughout your body. Some archaeologists speculate it was designed for ritual chanting or trance induction. But recent seismic monitoring has revealed something else. The chamber's resonant frequency matches the frequency of seismic waves generated by regional earthquakes. The chamber is, in effect, a natural amplifier for earthquake signals, enhancing them to the point where they'd be unmistakable to anyone present during seismic activity. They carved that chamber deep into solid rock, investing years of labor, creating a space where earthquakes would be not just detectable but overwhelming, a physical presence that would shake your bones and fill your awareness. Why? The only explanation that makes sense is that they wanted to experience earthquakes more intensely, wanted to feel the Earth's movement as completely as possible, wanted to be immersed in the phenomenon they were studying. That's the behavior of dedicated observers, of people treating geological phenomena not as random disasters but as signals to be decoded, patterns to be understood. And they succeeded. We know they succeeded because these cultures survived, flourished, built monuments that have outlasted empires. They lived on some of the most geologically active land on Earth, and they not only survived but created sophisticated civilizations. That wouldn't be possible through luck alone. It required knowledge, practice, the accumulated wisdom of generations who learned to read the Earth's language. But that knowledge didn't survive the disruptions of history. The catastrophes that ended the Ice Age, the migrations and conflicts that followed, the rise of new religious systems that dismissed the old practices as paganism, the shift from observation-based knowledge to text-based learning. All of these contributed to the loss of traditions that had been maintained for millennia. By the time of classical Greece, the earthquake temples were already ancient mysteries, their original purposes half forgotten. The Greeks knew the sites were sacred, knew they had something to do with prophecy and earth forces, but the specific practices, the detailed observation techniques, the accumulated knowledge of seismic patterns, that was fading into myth. By the Roman era, even the myths were fragmenting. The temples were maintained because tradition said they should be, but fewer and fewer people understood why they'd been built where they were built, what their architecture was designed to do. By the Middle Ages in Europe, they were ruins, stones in the landscape, sometimes repurposed for new buildings, sometimes avoided as pagan remnants, sometimes just ignored. And the knowledge they represented, the understanding that you could study the Earth through direct perception, that geological forces followed patterns accessible to patient observation, that the right kind of architecture could serve as an instrument for perceiving phenomena beyond normal human awareness, that knowledge disappeared almost completely from the Western tradition. It survived longer in other cultures. Traditional knowledge systems in China, Japan, India, and the Americas maintained some elements of seismic awareness, encoded in ritual and practice if not always in explicit theory. But even there, the rise of modern science and the cultural disruptions of colonialism and industrialization eroded the old traditions. By the 20th century, when seismology emerged as a modern science, complete with instruments and equations and predictive models, almost no one remembered that there had been another way of studying earthquakes, one based not on instruments but on human perception enhanced by architecture and sustained observation. We had to rediscover everything from scratch, building our knowledge on instrumental measurements, developing our theories through mathematical modeling, approaching the Earth as an object to be measured rather than a presence to be experienced. And we've made tremendous progress. Modern seismology can tell you things the ancient Earthwatchers never dreamed of: the precise structure of Earth's interior, the detailed mechanics of plate tectonics, the distribution of seismic risk across the globe. We can deploy networks of sensors that monitor ground motion with incredible precision, can model rupture dynamics with supercomputers, can issue warnings seconds to minutes before strong shaking arrives. But we still can't predict earthquakes. Despite all our instruments and all our theory, we can't tell you when the next big earthquake will strike a given fault. We can calculate probabilities, 30% chance in the next 30 years, but we can't say next Tuesday at 3 p.m. The ancient Earthwatchers might not have been able to predict with that precision either. But what if they could predict at timescales useful for their societies? What if they could sense days or hours before a major earthquake that something was building, that the Earth was preparing to move? For a society without reinforced concrete and earthquake-building codes, a few hours' warning would be enormously valuable. Time to move away from unstable slopes, to secure food stores, to prepare for aftermath. And what if we've lost that capability not because it didn't work, but because we've lost the cultural context that made it possible, the multi-generational observational traditions, the architecture designed to amplify subtle signals, the training that taught people to recognize patterns in sensation and perception? What if we've traded a qualitative, experiential way of knowing the Earth for a quantitative, instrumental way, and in the process lost something valuable? This isn't to romanticize the past or suggest we should abandon modern seismology. The knowledge we've gained through instruments and mathematics is real and powerful. But perhaps it's incomplete. Perhaps there are aspects of earthquake phenomena that reveal themselves more readily to sustained observation than to sporadic instrumental measurement, patterns that emerge over decades or centuries of watching rather than in the few decades we've had modern seismometer networks. And perhaps some of those patterns are encoded in the ruins the ancient Earthwatchers left behind, waiting for us to learn how to read them. Because that's what we're doing now, slowly and almost accidentally. We position our seismometers near ancient sites and discover that the sites have interesting acoustic or seismic properties. We study the architectural features of temples and find they function as resonators or amplifiers. We map the distribution of sacred sites and realize they cluster in seismically and volcanically active zones. We translate ancient texts and find references to earthquake prediction, to earth listening, to practices we dismissed as superstition but which contain observational details we're only now recognizing as potentially meaningful. We're excavating not just physical ruins but knowledge ruins, fragmentary remains of understanding that was once whole and coherent. And sometimes, in rare moments, we get glimpses of what that understanding might have looked like when it was alive and practiced. There's a tradition in Japanese Shinto that only recently came to Western scientific attention. At certain shrines, particularly older ones in seismically active regions, there are priests called Jishin Matsuri, or earthquake ritualists. Part of their role involves sitting in meditation in specific locations within the shrine grounds, often in small structures built over bare rock or near underground water features. They describe their practice as listening to the Earth's breathing, and they claim that through years of practice they can sense changes in the Earth's mood or tension that precedes seismic activity. Western scientists mostly ignored this as superstition until a 2009 study by researchers at Kyoto University decided to actually test it. They positioned seismic instruments at several of these shrine meditation sites and compared the recorded ground motion to sites just a few hundred meters away. They found that the meditation sites were all positioned at locations with unusual seismic characteristics, either enhanced ground motion at specific frequencies or sensitivity to seismic waves arriving from particular directions or correlation with groundwater fluctuations. The shrines had been built, centuries or millennia ago, in locations that a modern seismologist using instruments would identify as good spots for monitoring earthquake activity. The priests hadn't chosen these locations randomly or through divine inspiration. They'd chosen them through observation, through the accumulated knowledge of generations who'd learned where the Earth's signals were clearest. The study didn't prove that the priests could actually predict earthquakes, That would require much more extensive testing. But it demonstrated that they'd preserved, through tradition and practice, knowledge about site selection that was geologically meaningful. They'd maintained a connection to something real, even if the framework they used to understand it was mythological rather than scientific. This is what we're finding again and again. Beneath the mythology, beneath the rituals, beneath what we dismissed as primitive superstition, there are practices based on careful observation, knowledge accumulated through experience, traditions that preserved real information about the natural world. The earthquake temples were part of this. Not just religious sites, but observation posts. Not just monuments to gods, but instruments for perception. Not just architecture, but technology, a different kind of technology than we're used to, one based on enhancing human capabilities rather than replacing them with machines, but technology nonetheless. And the people who built them and maintained them across millennia were scientists of a sort. Observers, experimenters, knowledge keepers. They lacked our instruments and our mathematics, but they had something we've largely lost: time. Generations upon generations of sustained observation, of patient watching, of accumulated experience distilled into practice and preserved through tradition. What might you learn about earthquakes if you watched for 1,000 years? What patterns might emerge from such sustained attention? What subtle correlations might become visible given enough time and enough observers? We'll probably never know the full extent of what they discovered, because so much has been lost. The temples are ruins now, silent stones. The rituals are gone, the training methods forgotten, the accumulated observations unrecorded or recorded in ways we cannot read. But the stones remain, and they still sit where they were placed, still mark the seismic zones and the fault lines, still demonstrate through their acoustic properties what they were designed to do. They're waiting for us to ask the right questions, to approach them not just as archaeological curiosities but as the remnants of a knowledge system we might still learn from. Because here's the thing that modern earthquake science is slowly, reluctantly beginning to acknowledge. There might be limits to what instrumental prediction can achieve. The physics of earthquake rupture involves so many variables at so many scales, from the microscopic properties of rock friction to the continental scale of tectonic stress accumulation, that perfect prediction might be impossible even in principle. The system might be too complex, too sensitive to unmeasurable initial conditions, too chaotic in the mathematical sense. But imperfect prediction that works sometimes, that gives hours or days of warning rather than precise timing, that's based on recognizing patterns rather than calculating outcomes, that might be achievable. And it might be achievable not through more instruments or better models, but through a different approach entirely. Through human observers trained to recognize subtle correlations, positioned in locations that amplify relevant signals, maintaining observational baselines measured in decades rather than years. That was the ancient approach. And it worked well enough that cultures using it survived and flourished in regions where earthquakes should have made permanent settlement nearly impossible. Could we recreate something like it? Could we take what we know from modern seismology and combine it with the principles encoded in the ancient seismic temples, the ideas of architectural amplification, of positioned observation, of long-term pattern recognition through sustained human attention? Some researchers are starting to explore this. There are pilot projects using citizen scientists to report unusual phenomena before earthquakes. Changes in well water levels, anomalous animal behavior, unusual cloud formations, strange lights in the sky. The data is messy and the correlations are inconsistent, but some patterns are emerging. Just as the ancient priests might have reported, there do seem to be precursor phenomena, observable at the surface, that sometimes precede earthquakes. The challenge is filtering signal from noise, learning which observations are meaningful and which are just random variation. That's where the ancient advantage becomes clear. They had time, centuries to observe, to test, to refine their understanding of what mattered and what didn't. We're trying to compress that learning into a few years of modern study, and it's not working very well. But perhaps we could accelerate the process by studying what the ancients encoded in their architecture. By understanding why they chose the sites they chose, how they designed the acoustic properties they designed, what specific phenomena they were trying to amplify and observe. The ruins could be teaching tools, preserved lessons about how to listen to the earth. There's something profound and humbling about that idea, that the oldest structures humanity ever built might contain knowledge we still need, that the stones might still have something to say if we learn how to hear them. It inverts our usual assumptions about progress. We think of ourselves as advanced, the ancients as primitive. We imagine that we've surpassed them in every way that matters, that whatever they knew we now know better. But what if that's wrong? What if there are domains of knowledge where they achieve things we haven't matched, where their different approach and their vastly longer observational baseline gave them insights we're still struggling to rediscover? Earthquake prediction might be one of those domains. Not because they had better instruments, they had none. Not because they had better theory, they had no plate tectonics, no seismology, no mathematical models of rupture mechanics. But because they had centuries of patient observation, encoded in practices and places, sustained by cultures that valued that kind of knowledge enough to invest enormous resources in maintaining it. And because they understood something we've forgotten, that the earth is not silent, not inert, not unresponsive to attention. That it speaks, in its own language of vibration and chemistry and electromagnetic fluctuation, to those who position themselves to listen. The temples on the fault lines were listening posts. The priests were listeners. And what they heard, over generations of dedicated attention, was enough to let their civilizations survive in places where the ground itself was unreliable, where the foundation of their world could shift and rupture without warning. That's not myth. That's not superstition. That's knowledge, hard-won and carefully preserved. And then it was lost. Lost to catastrophe and cultural change, to the shifts in worldview that came with new religions and new ways of organizing knowledge. Lost so thoroughly that by the time modern archaeology began excavating these sites, we'd forgotten they had any practical purpose at all. We saw ritual where there had been observation, superstition where there had been empirical practice. We're only now beginning to remember. Only now starting to recognize that the ancients might have been doing science using different methods, based on different assumptions about how knowledge is acquired and preserved, but science nonetheless. And that recognition changes how we approach the ruins. Instead of just cataloging and preserving them, we can study them as functioning systems, can try to understand what they were designed to do and whether we can learn from that design. Some of that learning is happening. Acoustic archaeologists study the sound properties of ancient structures, revealing sophisticated understanding of resonance and reverberation. Archaeoastronomers decode the astronomical alignments, showing that ancient observers tracked celestial cycles with remarkable precision. Now we need archaeoseismologists, researchers who study ancient structures not just as monuments but as instruments for geological observation, who try to reconstruct the practices and knowledge systems that made those structures meaningful. The field is just beginning. There are only a handful of researchers working on it, usually people trained in both archaeology and earth science, people willing to take seriously the idea that ancient cultures might have developed sophisticated seismic monitoring capabilities without modern instruments. But the evidence keeps accumulating. Every time someone puts seismometers near an ancient site and discovers interesting properties. Every time someone finds another temple on a fault line, another oracle positioned over a gas-emitting fissure, another sacred site that turns out to have unusual geological characteristics. Every time traditional knowledge is documented and found to contain accurate observational details about earthquakes or volcanic eruptions or other geological phenomena. The pattern is too consistent to be coincidence. There was a global tradition of Earth observation, practiced by cultures, that supposedly had no contact with each other, maintained across millennia, encoded in architecture and ritual and oral tradition. And it worked. Not perfectly. Plenty of ancient cities were destroyed by earthquakes, plenty of temples collapsed in the very seismic events they might have been built to monitor. But well enough that the tradition persisted, that the knowledge was valued enough to be preserved and passed forward, that resources continued to be invested in maintaining the monitoring sites even after the original understanding had begun to fade. What finally killed it wasn't failure. It was cultural change. The shift from oral to written knowledge, from observation to authority, from direct perception to textual interpretation. The rise of religious systems that claimed truth came from divine revelation rather than natural observation. The development of philosophical traditions that separated human knowledge from natural phenomena, that treated the earth as inert matter rather than dynamic presence. By the time of the scientific revolution, when careful observation of nature began to be valued again, The ancient tradition was so thoroughly forgotten that the early scientists had to rediscover everything from scratch. They developed instruments because they'd lost the observational practices. They developed mathematics because they'd lost the pattern recognition. They developed institutional science because they'd lost the cultural continuity that had sustained knowledge across generations. And in many ways, this was necessary and valuable. The scientific method, with its emphasis on reproducibility and mathematical modeling and instrumental verification, has given us knowledge the ancients never had. We understand the deep structure of Earth, the physics of earthquakes, the chemistry of rocks and atmosphere. We can measure things they couldn't, model processes they couldn't, explain phenomena they had to attribute to gods or spirits. But we've also lost something. Lost the understanding that some knowledge comes through long observation rather than quick measurement. Lost the appreciation for practices that can't be reduced to equations but still produce reliable insights. Lost the idea that human perception, properly trained and properly positioned, can detect patterns that instruments might miss. The seismic temples remind us of that loss. They stand as monuments not just to ancient religious beliefs but to a different way of knowing the world. A way based on sustained attention, on embodied experience, on the integration of human awareness with natural processes. And they pose a question that we're only now beginning to take seriously. What if we could combine the ancient approach with modern knowledge? What if we could take the principles of long-term observation, architectural amplification, and trained perception, and integrate them with what we know from seismology and plate tectonics and materials science? What might we be able to perceive then? What patterns might emerge if we position trained observers in carefully designed structures at seismically active locations and maintain those observations for decades? What could we learn about earthquake precursors, about the subtle signals that precede rupture, about the ways the Earth communicates its stress and strain? We won't know unless we try, unless we're willing to see the ancient monuments not just as relics but as prototypes, early versions of technologies we might recreate and improve with modern understanding. That's beginning to happen. There are researchers designing buildings with specific acoustic properties to enhance perception of seismic signals. There are programs training observers to recognize earthquake precursors, using both instrumental data and reported phenomena. There are studies of traditional knowledge, documenting practices that sustained cultures have maintained for recognizing seismic risk. It's tentative and controversial because it challenges the purely instrumental approach that dominates modern seismology. But it's happening, driven by the recognition that despite all our instruments, we still can't predict earthquakes, and that perhaps there's value in exploring approaches that don't rely solely on machines. And always, in the background, there are the ruins. The temples on the fault lines, the oracles over the fissures, the stone circles marking geological boundaries. Silent now, their original purposes mostly forgotten. Their builders long dead and their cultures transformed beyond recognition. But still there. Still positioned where they were placed millennia ago. Still demonstrating through their architecture what they were designed to do. Still waiting for us to understand what they represent. They're not just monuments to the past. They're messages to the future. Built by people who understood that knowledge is fragile, that civilizations fall and are forgotten, that the only way to preserve crucial understanding across vast spans of time is to encode it in stone and placement, in structures so massive and so deliberately positioned that they'll still be visible even after everything else is lost. What was the message they were trying to preserve? At its simplest, the Earth speaks. Learn to listen. Position yourself where the signals are strongest. Build structures that amplify what matters. Observe patiently across generations. Recognize patterns. Remember, that message is still there, carved in stone and written in placement, waiting in the ruins for anyone who learns to read it. And perhaps we're finally ready to receive it. After centuries of seeing the ancient monuments as primitive superstition, we're beginning to recognize them as sophisticated responses to real challenges, as embodiments of knowledge acquired through long experience and careful observation. We're beginning to see that the people who built on fault lines weren't ignorant of the danger. They were experts in it, more experienced with seismic hazards than we are, having lived with them for countless generations, having developed practices for surviving and even thriving in environments where the ground itself couldn't be trusted. They positioned their most important structures in the most dangerous places because those were the monitoring stations, the observation posts, the places where the Earth's signals were clearest and strongest. They built them to last not just centuries but millennia because they understood they were preserving knowledge for a distant future, for descendants who might have forgotten but who would still need to know. We are those descendants, and we're standing in the ruins they left, measuring with our instruments what they measured with their bodies, trying to understand with our equations what they understood through direct experience. And slowly, hesitantly, we're beginning to recognize that they might have something to teach us still, that the very oldest human technologies, observation, attention, sustained practice, knowledge encoded in place and ritual, might complement our newest technologies in ways we're only beginning to explore. This isn't about abandoning modern science. It's about enriching it, about recognizing that the scientific method, powerful as it is, isn't the only way humans have ever acquired reliable knowledge about the natural world. That there were other methods, other approaches, other ways of organizing attention and perception that produced real insights. And that some of those insights, preserved in fragmentary form in ancient traditions and ancient structures, might still be valuable, might still offer perspectives we've lost, might still reveal patterns we've missed, might still teach us things about the Earth and our relationship to it that we desperately need to know. Because we're living through a time of geological upheaval again. Not as dramatic as the end of the Ice Age, perhaps, but significant nonetheless. Human activity is altering the planet at scales and speeds unprecedented in our species' history. We're changing the climate, acidifying the oceans, triggering earthquakes through fluid injection and reservoir impoundment, reshaping the surface of the continents through mining and agriculture and urbanization. And we're mostly doing this without the kind of long-term observational framework that would let us understand the full consequences of our actions. We measure and model, yes, but our baseline is short, a few decades, at most a century or two of reliable instrumental records. We're making planetary-scale changes based on understanding accumulated over time spans shorter than many individual human lifetimes. The ancient Earth Watchers thought in terms of generations and centuries. Their knowledge was accumulated over timescales that dwarf modern science's historical record. They understood, in a way we've forgotten, that the Earth changes slowly, that patterns emerge only through sustained observation, that some truths about the natural world reveal themselves only to patient attention maintained across many human lifetimes. We need that perspective now. Need the humility to recognize that decades of instrumental measurement, however precise, might miss patterns visible only across centuries. Need the wisdom to value long-term observation and cultural memory alongside the quick results that modern research prioritizes. The ruins on the fault lines can teach us that, if we let them, not through mystical revelation, not through channeling ancient spirits, but through careful study of what they represent. A different approach to knowledge, one based on sustained observation and cultural continuity, on the integration of human perception with natural processes, on the understanding that the Earth is not a static object to be measured but a dynamic system to be engaged with. That engagement requires presence, requires being in places where the Earth's activity is tangible, where its processes are visible and felt, requires attention sustained not just for the duration of a research project or a career, but across generations, requires institutions and practices designed to preserve knowledge across cultural changes and catastrophes. The ancient cultures built those institutions in stone. Their temples were universities. Their rituals were curricula. Their priests were professors maintaining traditions of observation and practice. The system wasn't perfect. Plenty was lost even before the great disruptions of history scattered and transformed the old cultures. But it worked well enough to preserve crucial knowledge for thousands of years, to maintain practices and understandings across spans of time that modern institutions have never matched. What would it take to build something similar now? Not a return to ancient religion or ancient technology, but a new synthesis, taking the principles of long-term observation, sustained attention, and embodied perception from the ancient tradition, and combining them with modern understanding of earth science, materials engineering, and information systems. What would a modern earthquake temple look like? Perhaps a structure positioned on a fault line, designed with acoustic properties to amplify seismic signals, equipped with both traditional observation spaces and modern instruments, staffed by people trained in both seismology and contemplative practice, maintained across generations as a long-term monitoring station and a school for Earth observation. It sounds fantastical, But is it really more fantastical than what the ancients achieved? They built Göbekli Tepe when humans supposedly had nothing but stone tools and oral culture. They raised monuments that have lasted 10,000 years. They developed and maintained knowledge systems sophisticated enough that we're still trying to fully understand them. We have advantages they lacked: powered tools, global communication, accumulated scientific knowledge. If they could build earthquake temples that functioned for millennia, surely we could build new ones that integrate ancient wisdom with modern understanding. And perhaps we need to, because earthquakes aren't going away. Seismic hazard continues to threaten millions of people worldwide. Despite all our engineering advances, major earthquakes still kill tens of thousands, still destroy cities, still disrupt societies. And we still can't predict them, still can't give people the warning they'd need to truly prepare. Maybe we've been approaching the problem wrong. Maybe prediction isn't about more sensors or better models. Maybe it's about recreating the observational practices the ancients developed, the sustained attention that let them recognize patterns we're missing with our instrumental, short baseline approach. Maybe the answer isn't in the future but in the past, encoded in structures we've been treating as archaeological curiosities rather than prototypes for technologies we could recreate and improve. This is the gift the ancient Earthwatchers left us. Not final answers, not complete knowledge, but a different way of asking questions, a different approach to understanding the Earth and our place on it. They built on fault lines to remind us that danger and knowledge are often found in the same places, that the most valuable insights come from engaging with risk rather than avoiding it, that the Earth speaks most clearly in the places where its power is most evident. They built structures to amplify seismic signals to show us that perception can be enhanced through architecture, that the built environment can serve as instrument, that human bodies and human awareness can detect patterns that machines might miss if we position ourselves correctly and train ourselves properly. They maintained their practices across generations to demonstrate that some knowledge requires time to accumulate, that truth about natural systems reveals itself slowly, that understanding the Earth requires commitment measured not in years but in centuries. And they encoded all of this in stone, in the most permanent form they knew, because they understood that knowledge is fragile, that cultures change and forget, that the only way to send a message to the far future is to write it in structures so massive and so deliberately placed that they can't be ignored or misinterpreted. We're reading that message now, slowly, partially, but with growing understanding. We're recognizing that the ruins aren't just graves of dead religions but preserved fragments of living knowledge, that the temples weren't just houses for imaginary gods but instruments for perceiving real phenomena, that the ancient Earthwatchers weren't primitive mystics but sophisticated observers developing empirical understanding through methods different from but not inferior to modern science. And as we recognize this, as we begin to take seriously the idea that we might learn from them, we open possibilities that have been closed for centuries. The possibility that there are multiple valid ways to acquire knowledge about nature. The possibility that long-term observation and trained perception might complement instrumental measurement. The possibility that the Earth does communicate with those who learn its language, that seismic patterns might be more accessible than we've assumed, that prediction might be achievable through approaches we've dismissed or forgotten. None of this is certain. The evidence is fragmentary, the interpretations contested, the practical applications still mostly theoretical. But the questions are worth asking, the possibilities worth exploring. Because the alternative, continuing to approach earthquakes solely through the instrumental methods that have so far failed to achieve prediction, hasn't been working very well. And because the ruins are there, still waiting, still positioned on their fault lines, still demonstrating through their architecture what they were designed to do. Still asking us to consider that the people who built them might have known something worth knowing, might have developed practices worth recreating, might have achieved understanding we've lost and need to rediscover. The temples on the fault lines aren't accidents. They're not monuments to ignorance or superstition. They're the preserved remnants of a knowledge system that approached the Earth as a living presence, that developed technologies for perceiving its movements and patterns, that maintained observational practices across timescales modern science has never matched. They're asking us a question, these ancient stones positioned in the most dangerous places on Earth. Not asking in words, but asking through their presence, through their deliberate placement, through the sophistication evident in their architecture. The question is this: are you listening? Are you paying attention to what the Earth is saying? Are you willing to position yourself where its voice is clearest, even if that means standing where the ground itself might betray you? Are you committed enough to observation to maintain it not just for years but for generations? Do you understand that knowledge about the Earth comes not from dominating it with instruments and equations, but from engaging with it, from presence and attention, from the patient work of learning a language not made of words? That's the question the temples ask. And they ask it still, 10,000 years after some of them were built, still standing in their dangerous places, still waiting for us to understand what they represent. We don't have to answer the way the ancients did. We don't have to rebuild their religious systems or adopt their mythological frameworks. But we do have to engage with the core insight they preserved, that the Earth speaks and that learning its language requires a different kind of attention than we're used to, a different kind of commitment than modern culture typically values, a different approach to knowledge than the instrumental method alone provides. If we can engage with that insight, if we can integrate what they knew with what we know, we might achieve something neither tradition could accomplish alone. We might develop a genuinely comprehensive approach to seismic understanding, one that combines the long baseline and trained perception of the ancient observers with the instrumental precision and theoretical sophistication of modern science. We might finally learn to predict earthquakes. Not perfectly, not with certainty, but well enough to save lives, well enough to make living on fault lines less of a gamble and more of an informed choice. Or we might not. The ancient knowledge is fragmentary, the modern science incomplete. The integration might be impossible, the whole idea a romantic fantasy about lost wisdom that never existed in the form we imagine. But we won't know unless we try. Unless we're willing to look at those ancient ruins not just as objects of archaeological interest but as potentially functional prototypes, as preserved hints about different ways of knowing and perceiving that we might recreate and improve. And that requires humility to admit that despite all our technological sophistication, we might have something to learn from people who built with stone tools and oral tradition. Humility to recognize that progress isn't always linear, that knowledge can be lost as well as gained, that the ancestors might sometimes have been wiser than the descendants. The temples on the fault lines demand that humility. They stand there, impossible and ancient, built in places that challenge our assumptions about what primitive peoples should have feared and avoided, designed with sophistication that challenges our assumptions about what they should have been capable of achieving. They refuse to fit comfortably into the story we tell ourselves about human progress, about the steady march from ignorance to enlightenment, from superstition to science. They suggest a more complicated narrative, one where knowledge accumulated and was lost, where sophisticated understanding existed long before we thought possible, where different approaches to knowing the world flourished and then were forgotten. That's an uncomfortable story. It challenges the triumphalism of modernity, suggests that we might not be as advanced as we think, implies that there might be domains where ancient peoples achieved things we haven't matched. But it might be a truer story than the simple narrative of progress. It might better account for the evidence we're finding, the sophisticated astronomical alignments in structures built before writing, the acoustic engineering in monuments raised before mathematics, the seismic monitoring in temples constructed before science. And if it's a truer story, then engaging with it honestly might teach us things the simpler narrative obscures. Might help us understand that knowledge is more fragile than we think, that cultural continuity is a prerequisite for preserving understanding across time, that some insights require observational baselines longer than individual lifetimes to accumulate. Might help us value the long view, the patient observation, the sustained attention that the ancient Earthwatchers practiced and that our quick result short baseline culture has mostly lost. Might help us build better institutions for preserving knowledge, institutions designed to last not decades but centuries, to maintain practices across cultural changes, to preserve understanding even through catastrophes. Might help us approach the Earth differently, not as a resource to exploit or a hazard to avoid, but as a presence to engage with, a system to observe and learn from, a teacher whose lessons require patience and attention to understand. The temples embody that approach. They're not fortifications against the Earth's power, they're interfaces with it, structures designed to enhance perception of geological processes, to make the Earth's voice more audible, to facilitate the kind of sustained observation that produces understanding. That's a radically different relationship with seismic hazard than the modern one, where we try to build structures that resist earthquake forces, that protect us from the shaking, that let us ignore what the ground beneath us is doing. We see earthquakes as disruptions to be minimized, as failures of the earth to remain stable and predictable. The ancient approach was to see earthquakes as communications, as messages from a living earth, as phenomena to be observed and learned from rather than merely endured or avoided. The temples were built in seismic zones precisely because those were the places where the earth was most communicative, where its processes were most visible, where observers could learn the most about its patterns and behaviors. Not because the builders were ignorant of danger, they knew earthquakes destroyed structures and killed people. The archaeological record shows repeated rebuilding after seismic damage. But they valued the knowledge gained from observation more than the safety of stable ground. They made a deliberate choice to prioritize learning over security, understanding over comfort. That's a choice our culture rarely makes. We prioritize safety, predictability, the elimination of risk. We build where the ground is stable, avoid where it's active, use engineering to minimize our exposure to natural hazards. And there's nothing wrong with that. It saves lives, preserves resources, lets societies develop without constant disruption. But it also distances us from natural processes, insulates us from direct experience of the Earth's dynamism, makes it harder to develop the kind of observational knowledge that comes from sustained engagement with geological activity. The ancient Earthwatchers didn't have that distance. They lived with earthquakes, experienced them regularly, had no choice but to engage with seismic hazard as a constant presence in their lives. And through that engagement, through generations of observation and experience, they learned things about earthquake patterns that our more distant, more protected approach might miss. They paid a price for that knowledge in damaged structures, in disrupted lives, possibly in deaths during major earthquakes. But they considered the price worth paying, considered the knowledge gained essential enough to justify the risks taken. We might disagree with that valuation. Our culture prioritizes individual safety, values human life above almost any other consideration. The idea of deliberately exposing people to seismic hazard in order to observe earthquake patterns would be ethically unacceptable to us. But we could achieve something similar without the same risks. We could build modern earthquake temples, structures positioned for observation but designed with all the safety features modern engineering provides. We could staff them with trained observers who choose to be there, who understand the risks and accept them in pursuit of knowledge. We could maintain them as long-term monitoring stations, places where both instruments and human observers track seismic activity over decades and generations. We could, in other words, recreate the ancient practice using modern understanding and modern safety standards, achieving the benefits of sustained observation without requiring the sacrifices the ancients had to make. That would be a genuine synthesis, a true integration of ancient wisdom and modern knowledge. It would honor what the temple builders achieved while improving on their methods, would preserve their insights while advancing beyond their limitations. And it might finally achieve what seismology has been pursuing for more than a century: reliable earthquake prediction, or at least significantly improved early warning. Not through instruments alone, not through models alone, but through the combination of instrumental precision, theoretical understanding, and trained human observation sustained over timescales long enough for meaningful patterns to emerge. That's the potential gift the ancient ruins offer us. Not mystical knowledge, not supernatural abilities, but a different methodological approach, a different way of organizing attention and observation that might complement what modern science does well with what it does poorly. Modern seismology excels at explaining earthquakes after they occur, at modeling the physics of rupture, at calculating long-term probabilities. But it struggles with prediction, with recognizing the specific precursor patterns that might indicate an imminent earthquake. That's where human observers, trained to notice subtle correlations, maintaining observational continuity over long periods, might add value that instruments alone cannot provide. The instruments are better at precise measurement. The humans are better at pattern recognition, at noticing correlations across multiple variables, at integrating subtle signals that might be dismissed as noise in automated monitoring systems. Together, combining the strengths of both approaches, we might achieve what neither can accomplish alone. But that requires us to take the ancient temples seriously, to study them not just as monuments but as functional systems, to try to understand what they were designed to do and whether we can learn from that design. It requires us to engage with the uncomfortable possibility that the ancients might have known things we don't, might have developed capabilities we've lost, might have achieved understanding that our more advanced civilization has failed to match. That's hard for modern culture to accept. We're used to thinking of ourselves as the pinnacle of human achievement, the most knowledgeable generation that has ever lived. The idea that Stone Age peoples with no writing and no instruments might have developed sophisticated seismic monitoring capabilities challenges that self-conception. But the evidence keeps mounting. The temples on the fault lines, the acoustic properties that amplify seismic signals, the traditional knowledge that preserves accurate information about earthquake patterns, the mythological accounts that contain observational details we're only now recognizing as potentially meaningful. All of it points to the same conclusion. There was a tradition of earthquake observation in the ancient world, a tradition that used different methods than modern seismology, but that produced real knowledge practical enough that cultures maintained it for thousands of years. And that tradition encoded its practices in architecture, in the deliberate design of structures that would enhance perception of seismic phenomena, in the positioning of those structures in locations where the Earth's activity was most evident. The temples were textbooks, in a sense, teaching tools designed to show each generation how to listen to the Earth, where to position themselves for best perception, what to pay attention to, how to recognize patterns. They're still teaching these ancient structures, still positioned where they were placed millennia ago, still demonstrating through their architecture what they were designed to do, still available as examples, as prototypes, as preserved hints about approaches to seismic monitoring that we might recreate and improve. But they're also fragile. Weathering and erosion slowly destroy them. Archaeological excavation, however careful, alters them. Tourism and development threaten many sites. And our own lack of understanding sometimes leads to preservation strategies that emphasize maintaining the stones while missing the significance of location, of acoustic properties, of the functional aspects that made these structures meaningful beyond their role as monuments. We need to preserve them not just as archaeological sites but as knowledge repositories, as examples of technologies we might still learn from. Need to study them not just with archaeological methods but with acoustic analysis, seismic monitoring, geological surveying, all the tools necessary to understand how they functioned as instruments for Earth observation. And we need to do this quickly while traditional knowledge about some of these sites still exists, while there are still cultures maintaining practices that descend from the ancient traditions, while we can still interview practitioners and observe rituals that might preserve fragments of the original knowledge systems. Because that knowledge is disappearing as rapidly as the physical structures. The last Earthwatchers, the last practitioners of traditional seismic observation, are dying. The cultural contexts that made their practices meaningful are being eroded by modernization and cultural change. Within a generation or two, much of what survives of the ancient tradition will be gone, preserved only in fragmentary written accounts and in the stones themselves. If we want to learn from the ancient Earthwatchers, we need to act now. Need to document what remains, need to study the structures while we can still find people who remember their traditional uses, need to experiment with recreating the observational practices before the last knowledge of them is lost. This isn't about romantic nostalgia for a lost golden age. It's about practical archaeology, about recovering knowledge that might still be useful, about learning from human experiences that span far longer timescales than modern science has existed. It's about recognizing that the people who built on fault lines weren't our primitive ancestors making ignorant mistakes, but rather our sophisticated predecessors making informed choices, developing technologies and practices suited to their understanding and their needs, achieving things we haven't matched despite our advantages in tools and theory. They listened to the Earth. They built instruments to hear it more clearly. They maintained observational traditions across spans of time that dwarf modern institutions. They encoded their knowledge in the most permanent form they knew, in stone and placement, in architecture designed to last millennia. And now we stand in the ruins of what they built, trying to understand what they achieved, trying to learn from their example, trying to recover fragments of wisdom that might help us address challenges they faced and survived but that we're still struggling to manage. The temples on the fault lines are asking us to reconsider what we think we know about human capabilities, about the relationship between ancient and modern knowledge, about the ways understanding can be acquired and preserved. They're asking us to be humble enough to learn from the past, curious enough to explore methodologies different from our own, patient enough to value knowledge that accumulates over generations rather than in quick research projects. They're asking us to listen not just to them but to what they listen to the earth itself, to its slow language of stress and strain, to the patterns hidden in vibration and chemistry and electromagnetic variation, to the signals that precede rupture and might, if we learn to recognize them, give warning of earthquakes to come. That's the deepest lesson the ancient Earthwatchers left us. Not any specific fact about seismic patterns, not any particular technique for prediction, but the fundamental insight that the Earth does speak, that its processes are not random and incomprehensible but patterned and potentially knowable, that sustained observation by trained perceivers can reveal truths that instruments alone might miss. It's an insight that cuts against the grain of modern scientific culture, which tends to value instrumental measurement over direct perception, to trust machines more than human observers, to see objectivity as requiring distance and detachment rather than engagement and presence. But perhaps both approaches have value. Perhaps the ideal is not to choose between instruments and observation, between models and experience, between the modern and the ancient, but to integrate them, to build systems that combine the precision of machines with the pattern recognition of minds, that use mathematical models to explain what sustained observation reveals, that honor both the quick results of modern technology and the patient accumulation of knowledge over generations. That integration would be something new in human history, a genuine synthesis of the ancient earth-watching tradition and modern seismology, combining the strengths of both while compensating for the limitations of each. And the temples on the fault lines could serve as inspiration and model for such a synthesis. Not because we'd rebuild them exactly as they were. Our understanding and our capabilities have advanced too far for simple recreation. But because they demonstrate principles we could apply using modern materials and methods. The principle of architectural amplification, of positioning structures to enhance perception of specific phenomena. The principle of sustained observation, of maintaining monitoring stations across generations. The principle of training observers to recognize subtle patterns, of treating human perception as an instrument that can be refined and calibrated. These principles, applied with modern understanding of acoustics, materials science, earth science, and cognitive psychology, could produce earthquake monitoring systems more sophisticated than anything the ancients achieved, while still honoring the core insights their tradition preserved. Imagine a network of modern earthquake temples, carefully designed structures positioned at key locations along major fault zones, built with acoustic properties that amplify specific seismic frequencies, equipped with both state-of-the-art instruments and spaces for human observers, maintained as long-term research stations where scientists and trained perceivers work together to monitor earthquake precursors. Imagine these stations maintained not for the duration of a grant cycle or a career, but for generations, with institutional structures designed to preserve observational continuity even as individual researchers come and go. Imagine the data that would accumulate over decades of combined instrumental and observational monitoring, the correlations that might emerge between subtle precursor signals and subsequent earthquakes, the patterns that might become visible only through sustained attention over long time periods. Imagine the knowledge we might develop, the understanding we might achieve, the lives we might save through improved earthquake prediction or early warning. That's the promise the ancient temples hold. Not mystical revelation, not supernatural knowledge, but the potential for a better approach to seismic monitoring, one that integrates what they learned with what we know, that combines their long baseline with our instrumental precision, that honors both tradition and innovation. But realizing that promise requires us to change how we think about ancient monuments, about the capabilities of pre-modern peoples, about the nature of knowledge and the ways it can be preserved. It requires us to see the ruins not as graves of dead superstitions but as libraries of living knowledge, as preserved fragments of understanding that might still teach us if we learn to read them properly. It requires us to approach the ancient Earthwatchers with respect rather than condescension, to recognize them as colleagues across time rather than primitive ancestors, to acknowledge that they achieved things we haven't matched despite our supposed advantages. It requires humility, and perhaps that's the hardest thing for modern culture to muster, the humility to admit that we might not know everything, that progress isn't always linear, that the ancestors might sometimes have been wiser than the descendants. But without that humility, we'll never learn what the temples have to teach. We'll continue to treat them as archaeological curiosities, as monuments to primitive beliefs, as evidence of how far we've advanced rather than as examples of what we might reclaim. And we'll continue to struggle with earthquake prediction, continue to lose lives and cities to seismic events we might have anticipated if we'd been willing to learn from those who came before us, who lived with earthquakes for countless generations, who developed practices and knowledge we've dismissed as superstition but which might contain truths we desperately need. The temples are waiting, patient as stone, silent as earth, positioned on their fault lines where they've stood for thousands of years, waiting for us to ask the right questions, to study them with the right methods, to approach them with the humility necessary to learn from the past, waiting for us to understand that they're not just monuments to what was, but invitations to what might be, to a synthesis of ancient wisdom and modern knowledge, to an integration of observation and instrument, to a relationship with the earth that honors both its power and its pattern, both its danger and its communication. Waiting for us to realize that the civilization that predicted earthquakes before science was invented might have something to teach the civilization that has science but cannot yet predict earthquakes. The answer is there, encoded in stone and placement, in the acoustic properties of ancient chambers and the geological positioning of sacred sites, in the preserved fragments of traditional knowledge and the mythological accounts we've dismissed as fantasy. The answer is there in the simple, profound fact that they built on fault lines not despite the earthquakes but because of them, because they understood that danger and knowledge often occupy the same space, that the most valuable insights come from engagement with what we fear, that understanding requires presence where the phenomena we study are most evident. We've forgotten that. We build our cities where the ground is stable, position our research institutions where it's safe and comfortable, study earthquakes from a distance using instruments that let us avoid direct exposure to seismic hazard. And there's nothing wrong with that. It's safer, it's more efficient, it protects valuable equipment and valuable lives. But it also distances us from the phenomena we're trying to understand, filters our experience. Through layers of instrumentation and abstraction, makes it harder to develop the kind of intuitive knowledge that comes from sustained, direct engagement. The ancient Earthwatchers didn't have that distance. They lived where the earthquakes were, felt them regularly, experienced the full sensory reality of the ground moving beneath them. And through that direct engagement, through generations of paying attention to what they felt and when, they developed understanding we're still trying to match. That's the core lesson. That's what the temples on the fault lines are teaching us, if we're willing to learn. Not that we should abandon instruments or mathematical models or the safety measures modern engineering provides, but that we should complement those tools with the direct observation, the sustained attention, the patient accumulation of experience across generations that the ancient tradition exemplified. That we should position ourselves, sometimes, where the Earth's activity is most evident, even if that means accepting some risk. That we should train observers to pay attention to subtle signals, to recognize patterns in sensation and perception, to integrate information across multiple modalities in ways that instruments measuring single variables might miss. That we should build institutions capable of maintaining observational continuity across decades and generations, preserving knowledge through cultural practice and not just written records or digital databases. That we should, in short, take seriously the possibility that there might be multiple valid paths to understanding earthquakes, and that the ancient path, though different from the modern one, might still have value, might still reveal truths we're missing, might still achieve results our supposedly more advanced methods have failed to produce. This is uncomfortable territory for modern science, which has largely defined itself in opposition to traditional knowledge, which has built its authority on claims to objectivity and reproducibility that seem incompatible with the subjective, experiential, culturally embedded nature of ancient earth-watching practices. But perhaps that opposition was always too stark, too absolute. Perhaps there's room for both approaches, for a science that values both measurement and observation, both mathematical models and embodied experience, both instrumental precision and long-term pattern recognition by trained perceivers. Perhaps the temples on the fault lines are inviting us toward such a synthesis, toward a more comprehensive approach to understanding the Earth that honors both what the ancients learned and what we've discovered, that integrates their methods with our technologies, that builds on their foundation rather than dismissing or ignoring it. If we accept that invitation, if we're willing to learn from the ruins, what might we achieve? We might finally develop reliable earthquake prediction, or at least significantly improved early warning. We might save thousands of lives currently lost to seismic disasters. We might make living in seismically active regions safer and more sustainable. But beyond those practical benefits, we might gain something more profound. A different relationship with the Earth itself, one based not on domination or exploitation but on attention and respect, not on trying to force the planet to conform to our expectations but on learning its patterns and adapting to its rhythms. We might rediscover what the ancient Earthwatchers knew, that the Earth is not dead matter, not a passive stage for human drama, but a dynamic presence, a living system that communicates with those who learn its language. That communication doesn't require supernatural belief. It doesn't require abandoning scientific materialism or embracing mysticism. It simply requires recognition that complex natural systems generate patterns, that those patterns can be perceived and learned, that observation sustained over sufficient time can reveal regularities that shorter-term study misses. The Earth does speak, in seismic waves and electromagnetic variations, in gas emissions and groundwater fluctuations, in the slow accumulation of stress that precedes rupture. It speaks constantly, in a language made of physics and chemistry and geology. The ancient Earthwatchers learned to understand that language, at least partially, through sustained observation and direct engagement. They built temples on fault lines to position themselves where the Earth's voice was clearest. They designed those temples with acoustic properties that amplified the signals they were listening for. They maintained observational traditions across generations so that pattern recognition could accumulate beyond any individual lifetime. And they achieved something remarkable. Cultures that survived and flourished in some of the most seismically hazardous regions on Earth, that maintained continuity across millennia despite living where the ground itself was unreliable. That wasn't luck. That was knowledge, hard-won, carefully preserved, encoded in practice and place. And then it was lost. Not entirely, not all at once, but gradually, as cultures changed and catastrophes disrupted continuity, as new religions displaced old practices, as writing and later instrumental science became the dominant modes of preserving and transmitting knowledge. By the time modern seismology emerged, the ancient tradition had fragmented into myth and superstition, its practical basis forgotten, its achievements attributed to divine intervention rather than human observation. But the ruins remained, and they're still there, still positioned on their fault lines, still demonstrating what they were designed to do, still asking us to remember what was forgotten, to recognize what was lost, to consider whether we might reclaim and rebuild what our ancestors achieved. That's not regression. That's not abandoning progress for some romanticized vision of ancient wisdom. It's integration, taking what was valuable from the past and combining it with what we've learned since, building something new that's more than the sum of its parts. It's recognizing that knowledge accumulates not just forward through time but also backward, that sometimes the most important insights come from recovering what was lost, rather than from discovering what's entirely new. It's honoring the deep time of human experience, the countless generations who lived and observed and learned and passed their knowledge forward, who struggled with the same challenges we face and developed solutions we've forgotten. The Earthwatchers who built on fault lines were our predecessors in the most important sense. Not genetic ancestors necessarily, but intellectual and practical ancestors, people grappling with understanding seismic hazard, developing methodologies for observation and prediction, creating institutions to preserve knowledge across time. We're continuing their work, using different tools, working from different assumptions, embedded in different cultural contexts. But the fundamental task is the same: learning to understand earthquakes well enough to predict them, or at least to give warning that might save lives. They made progress on that task. Significant progress, judging by their culture's survival and the architectural sophistication of their monitoring stations. Progress they tried to preserve in the most durable form they knew, in stone monuments positioned where they couldn't be ignored or forgotten. We've made different progress using instruments and mathematics they couldn't have imagined. But we haven't yet achieved the goal. Reliable earthquake prediction still eludes us despite all our technology. Perhaps we need both approaches. Perhaps the integration of ancient observation and modern instrumentation, of direct perception and mathematical modeling, of traditions maintained across generations and rapid scientific advancement, could finally achieve what neither tradition has accomplished alone. That's the possibility the temples on the fault lines represent. Not a choice between ancient and modern, between tradition and science, between observation and instrument, but a synthesis that honors both, that combines the strengths of each while compensating for the limitations of either. And that synthesis might do more than improve earthquake prediction. It might model a new relationship between modern science and traditional knowledge more generally, might demonstrate that there's value in recovering and integrating ancient wisdom rather than simply dismissing it as primitive superstition. Might show that indigenous knowledge and scientific knowledge aren't opposing systems but complementary ones, that traditional observations sustained over long timescales can reveal patterns that scientific studies with shorter baselines might miss, that embodied experience and instrumental measurement can both contribute to comprehensive understanding. This is increasingly recognized in other domains, ecology, botany, medicine, where researchers are beginning to take traditional knowledge seriously, to study indigenous practices not as curiosities, but as potential sources of genuine insight. The same shift could happen in earth science, in seismology, in the study of geological hazards. And the ancient earthquake temples could be both the inspiration and the example, showing us that sophisticated earth observation existed long before modern instruments, that cultures developed and maintained seismic monitoring practices across millennia, that the ruins they left contain lessons we might still learn from. But only if we approach those ruins with the right questions, with the right methods, with the humility necessary to recognize that the builders might have known something worth knowing. Only if we study the temples not just as archaeological sites but as functional systems, analyzing their acoustic properties, their geological positioning, their architectural design for clues about how they were meant to function. Only if we combine that archaeological and architectural analysis with geological and seismological study, using modern instruments to measure what the ancients were perceiving, trying to understand what signals they were amplifying and why. Only if we document remaining traditional knowledge before it's entirely lost, interviewing practitioners, observing rituals, recording practices that might preserve fragments of the ancient earth-watching tradition. Only if we're willing to experiment, to try recreating aspects of the ancient approach using modern understanding and modern safety measures, to see whether trained observers in appropriately designed spaces can detect earthquake precursors that instruments alone might miss. That's a research program. Agenda for recovering and integrating ancient seismic knowledge. It's ambitious and uncertain. We don't know if it would work. Don't know if the ancient practices can be reconstructed from fragmentary evidence. Don't know if combining traditional observation and modern instrumentation would actually improve earthquake prediction. But we won't know unless we try. Unless we take the possibility seriously enough to invest resources, to conduct proper studies, to approach the question with the rigorous methods and careful analysis that any scientific inquiry demands. And the potential payoff justifies the effort. If even a fraction of what the ancient Earthwatchers achieved can be recovered and integrated with modern seismology, if trained observers in appropriately designed spaces can contribute to earthquake monitoring in ways that instruments alone cannot, if sustained observation over generations can reveal patterns invisible in shorter baseline studies, then we might finally make progress on prediction, might finally give people the warning that could save lives. That's worth pursuing. Worth the resources it would require, worth the methodological challenges it would pose, worth the discomfort of acknowledging that ancient peoples might have achieved things we haven't matched. Worth honoring what the temple builders tried to preserve, what they encoded in stone and placement, what they left for descendants who might remember or rediscover. Worth learning from the past, not out of nostalgia but out of recognition that human knowledge accumulates over vast timescales, that sometimes the most important insights come from deep history, that the ancestors who lived through countless earthquakes and learned to survive them might have something to teach us still. The temples on the fault lines are monuments to that possibility, to the idea that knowledge doesn't always flow linearly forward, that sometimes we need to look backward to move forward, that the ruins of the past might contain the seeds of future breakthroughs. They stand there still, patient and permanent, weathering slowly but enduring across millennia, positioned exactly where their builders placed them thousands of years ago. Still on the fault lines where the earth moves, still in the seismic zones where their original purpose made sense, still demonstrating through their architecture what they were designed to do. They've outlasted the cultures that built them, outlasted the knowledge systems they embodied, outlasted empires and religions and entire civilizations. They've survived catastrophes that would have destroyed anything less massively built, have persisted through climate changes and earthquakes and human conflicts. And they're waiting to be understood not just as monuments to dead religions but as preserved examples of living technology, as textbooks written in stone, as libraries of knowledge accessible to those who learn to read them properly. Waiting for us to recognize what they represent, to study what they can teach, to experiment with what they exemplify. waiting for us to build again on fault lines, not out of ignorance this time, but out of understanding. Not to escape the Earth's power, but to engage with it, to monitor it, to learn from it. Waiting for us to create new earthquake temples, modern versions that combine ancient wisdom with contemporary knowledge, that use both observation and instruments, that maintain monitoring across generations, that position themselves where the Earth speaks most clearly. Waiting for us to remember what they tried to preserve, that the Earth is not silent, not random, not incomprehensible, that it follows patterns, that it gives warnings to those who know how to listen, that sustained observation reveals truths that brief study might miss. That's the message carved into their foundations, built into their positioning, encoded in their architecture. A message not written in words or symbols but in stone and place, in the enduring relationship between human construction and geological reality. We're only beginning to read that message, only starting to understand what the ancient Earthwatchers achieved, what they tried to preserve, what they meant to teach future generations who might have forgotten the Earth's language but might still need to relearn it. The work of recovery has barely begun. Most of the ancient seismic sites have never been studied from the perspective of earthquake monitoring. Most of the traditional knowledge about earthwatching has never been documented. Most of the potential integration between ancient observation and modern instrumentation has never been attempted. But it could be. If we commit to it, if we invest the resources, if we approach the question with proper scientific rigor combined with appropriate humility about what the ancients might have known. If we do that work, if we learn what the temples can teach, we might finally answer the question that has haunted seismology since its inception. Can earthquakes be predicted? The ancient Earthwatchers thought they could be, at least sometimes, at least well enough to provide useful warning. They built their entire seismic monitoring system on that assumption, that observation sustained over generations could reveal patterns that trained perceivers positioned in appropriately designed spaces could sense the Earth preparing to move. Were they right? We don't know yet. We haven't reconstructed their methods well enough to test their effectiveness. We haven't combined their observational approach with our instrumental capabilities. We haven't maintained the long-term monitoring that their tradition exemplified. But we could find out. We could build modern earthquake temples as research stations. We could train observers in seismic awareness and position them where the Earth's signals are strongest. We could maintain those observations for decades, comparing what trained humans perceive with what instruments measure, looking for correlations between reported precursors and subsequent earthquakes. We could do all this while maintaining rigorous scientific standards, careful documentation, statistical analysis, peer review, reproducibility testing. We could approach traditional knowledge with scientific methods, bringing the tools of modern research to bear on ancient practices. That synthesis, rigorous science applied to recovered traditional knowledge, might be the most valuable thing the earthquake temples could teach us. Not specific facts about seismic prediction, but a methodology for integrating different ways of knowing, for honoring both modern and ancient approaches, for building on human knowledge accumulated across the full span of our species' history. That's what we need now, as we face challenges unprecedented in human history: climate change, environmental degradation, geological hazards threatening ever larger populations. We need all the knowledge we can access, from all the sources available, integrated in ways that honor both traditional wisdom and modern science. The temples on the fault lines could be models for that integration. They could demonstrate that ancient and modern, traditional and scientific, observational and instrumental can work together, can complement each other, can produce understanding neither achieves alone. But only if we let them, only if we approach them properly, study them thoroughly, learn what they have to teach. Only if we're willing to build on fault lines again, not physically for most of us, but intellectually and methodologically. Willing to position ourselves in uncomfortable spaces where our assumptions might be challenged, where our certainties might be shaken, where we might discover that what we thought we knew is incomplete. Willing to listen to the Earth and to those who listened before us. The ancient Earthwatchers are calling to us across millennia, their voices preserved in stone, their knowledge encoded in placement and design, their achievements waiting to be recognized and honored and built upon. They're asking, are you listening? Do you hear what the Earth is saying? Will you learn its language again? Or will you continue to treat it as silent stone, as dead matter, as unpredictable chaos rather than patterned presence? They're asking, will you honor what we learned through generations of patient observation? Or will you dismiss it as primitive superstition unworthy of serious attention? They're asking, will you preserve what we tried to preserve, the understanding that humans can learn the Earth's patterns, can develop sensitivity to its movements, can predict its ruptures well enough to survive and even flourish in the most seismically hazardous places on the planet? They're asking these questions through their ruins, through the temples that still stand where they were placed, through the acoustic properties and geological positioning and architectural sophistication that modern analysis reveals. And they're asking us to answer not with words but with actions, to study what they built, to experiment with recreating their methods, to integrate their observational approach with our instrumental capabilities, to build institutions that can maintain monitoring across generations as they did, to position ourselves sometimes where the Earth speaks most clearly, even if that requires accepting some risk, to remember, in short, what they tried to preserve, that the Earth is not silent, that its patterns can be known, that sustained attention reveals truths that casual observation misses. That's the legacy of the civilization that predicted earthquakes before science was invented. Not specific techniques we can directly copy, too much has been lost for simple recreation, but principles we can apply, approaches we can integrate with modern knowledge, inspirations for new syntheses that combine the best of ancient wisdom and contemporary understanding. The temples wait for us to claim that legacy, to build on their foundation, to continue the work they began thousands of years ago. They wait as they've waited for millennia, patient as stone, enduring as earth, positioned on their fault lines where the ground itself moves but the monuments remain. They wait in Turkey and Peru, in Greece and Japan, in Malta and Mexico and a dozen other places where ancient peoples built sacred sites in seismically active zones. Some are famous, visited by thousands of tourists who marvel at their age and scale. Others are obscure, known only to archaeologists and local residents. But all of them share the same essential characteristic. They're positioned where the Earth moves, where geological forces are most evident, where anyone paying attention can feel the planet's dynamism. They're teaching the same lesson, all of them, across continents and cultures and millennia. The Earth speaks. Learn to listen. That lesson is as relevant now as when the first Earthwatchers chose to build where the ground trembled. More relevant, perhaps, because we've grown so distant from direct experience of geological processes, so insulated by technology and infrastructure, so convinced that we can control nature rather than having to adapt to it. The ancient Earthwatchers had no such illusions. They knew they couldn't control earthquakes, couldn't prevent them, couldn't make the ground stable through engineering or willpower. All they could do was learn the patterns, develop sensitivity to the warnings, position themselves to perceive the precursors. And apparently, they succeeded well enough that their cultures invested enormous resources in maintaining the practice, in building permanent monitoring stations that would last beyond any individual lifetime, in training new generations of observers to continue the tradition. That investment only makes sense if the practice worked, if it provided real benefits, if it gave warning often enough and accurately enough to justify the costs. We don't have direct evidence that it worked. No ancient record saying, the Earthwatchers predicted the earthquake of such and such date and people evacuated and lives were saved. But we have indirect evidence in the very existence of the temples, in their sustained maintenance across millennia, in the survival and flourishing of cultures that lived in the most dangerous places on Earth. And we have the mythology, the stories of oracles who predicted earthquakes, of priests who sensed the Earth preparing to move, of individuals who could read signs in nature that warned of coming disasters. We've dismissed those stories as fantasy, as supernatural claims incompatible with scientific worldview. But what if they're garbled memories of real practices, of observational techniques that worked often enough to be remembered, even if the original understanding was lost? What if the Oracle of Delphi really could sense when earthquakes were coming, not through divine inspiration but through prolonged exposure to the gases and seismic signals at that geologically active site? What if the Telchines really could predict volcanic eruptions, not through magic but through careful observation of precursor phenomena? What if the earthquake ritualists of Japan really can perceive changes in the Earth's tension, Not through supernatural sensitivity, but through trained awareness of subtle signals. What if, in other words, the mythology preserves fragmentary memories of real capabilities, and the challenge is to separate the factual core from the supernatural embellishments? That's the work that needs doing. The careful, rigorous work of studying the ancient sites with modern methods, of documenting traditional practices before they're lost, of experimenting with recreating observational techniques, of testing whether trained humans in appropriately designed spaces can detect earthquake precursors that instruments alone might miss. It's difficult work, methodologically challenging, requiring expertise in multiple disciplines: archaeology, acoustics, geology, seismology, psychology, anthropology. It requires patience, because any proper test of long-term observation requires years or decades to produce meaningful results. It requires funding, because maintaining monitoring stations and training observers and conducting rigorous analysis all cost money. And it requires humility, because it means taking seriously the possibility that ancient peoples achieved things we haven't matched, that traditional knowledge might contain truths modern science has missed, that our technological sophistication might have blinded us to approaches that don't rely on instruments. That's perhaps the hardest requirement. Humility doesn't come easily to modern scientific culture, which has built its authority on claims to superior knowledge, which has defined itself partly through opposition to traditional beliefs and practices. But without humility, we'll never learn what the temples can teach. We'll continue to treat them as curiosities, as monuments to primitive beliefs, as evidence of how far we've progressed rather than as examples of what we've lost. And we'll continue to fail at earthquake prediction, continue to lose lives to seismic disasters we might have anticipated, continue to approach the earth as if it were silent stone rather than a communicative presence. The temples on the fault lines offer us another way. Not a return to ancient religion, not an abandonment of modern science, but an integration, taking what the Earth Watchers learned through millennia of observation and combining it with what we've discovered through centuries of instrumental study. That integration is possible. The ruins show us it's possible, demonstrate principles we could apply, preserve fragments of knowledge we could rebuild upon. But it requires us to change how we think, to recognize that knowledge accumulates over vast timescales, that sometimes the most important insights come from deep history, that the ancestors who lived through countless earthquakes might have learned things we've forgotten. To understand that the earth does speak, in its language of vibration and chemistry and electromagnetic fluctuation, to those who position themselves to listen. To remember what the temples were built to preserve. That humans can learn the earth's patterns, can develop sensitivity to its movements, can perceive what's coming if they pay attention long enough and carefully enough. The civilization that predicted earthquakes before science was invented is calling to us across the millennia. Their temples still standing on their fault lines, still positioned where the earth moves, still demonstrating what they were designed to do. They're asking, will you listen? Will you learn? Will you remember? The answer isn't certain. We might fail to recover what they preserved. We might lack the patience or the humility or the resources to recreate their observational practices. We might find that whatever they achieved can't be reproduced in our different cultural context, with our different assumptions and priorities. Or we might succeed, might integrate ancient wisdom with modern knowledge, might develop earthquake monitoring that combines observation and instrumentation, might finally achieve the prediction that has eluded seismology since its inception, might honor the legacy of the ancient Earthwatchers by continuing their work, by building on their foundation, by preserving in new forms what they tried to preserve in stone. The temples wait for us to choose. Wait on their fault lines, patient and permanent, enduring across millennia. They've been waiting a long time. They can wait longer, but the earth won't wait. It continues to move, to shift, to release stress in sudden ruptures that destroy cities and end lives. It continues to speak its language of vibration and strain, continues to give warnings to those who know how to listen. And somewhere, perhaps, there are still a few who remember how to hear it. A few practitioners of traditional earthwatching, maintaining practices passed down across generations, sitting in meditation in sacred spaces, feeling the earth breathe beneath them. They're the last link to the ancient knowledge, the living connection to traditions that stretch back thousands of years. When they're gone, that connection breaks. and all that will remain are the stones, silent monuments to a wisdom we've forgotten. Unless we learn from them now, unless we document their practices, study their methods, integrate their knowledge with modern understanding before it's too late. Unless we rebuild what was lost, not exactly as it was, but in new forms appropriate to our time and understanding. Unless we honor the temples by understanding what they represent. Not monuments to primitive superstition, but preserved examples of human ingenuity, sophisticated responses to the challenge of living with earthquakes, technologies for perceiving what the earth is saying. The civilization that predicted earthquakes before science was invented has left us their legacy, carved in stone, positioned on fault lines, waiting to be understood. Will we learn what they tried to teach? Will we remember what they fought to preserve? Will we listen to the earth as they listened? The temples are asking. The earth is speaking. And we, the descendants of the ancient earth-watchers, inheritors of both their wisdom and their forgetting, stand at the threshold of choice. Will we cross it? The answer will determine not just whether we achieve earthquake prediction, but what kind of relationship we have with the planet that sustains us, what kind of knowledge we value, what kind of legacy we leave for future generations. The temples wait. The earth speaks. The choice is ours.